All right, so let's look at question 6 from yesterday. Why is everything moving? Everything's moving. Let's fix that. You are right there. Now you are coming over here. There it is. There we are. Okay, so in this section we're just looking at factoring. So let's kind of take a closer look at some of these questions and remember how to factor. I can't make that any bigger, but although we didn't specifically talk about factoring by decomposition in this section, factoring by decomposition is the thing that we should know how to do from last year. But if you don't remember, go back to chapter 3, go on to Mathtopia. Can I see anything right now? There it is. Go on to Mathtopia, and you're going to see it there. Okay? Of course it's not there. We go here. Do this all over again. Can't see my thing.
Can you show us the quote again?
The quote?
Yeah,
What quote?
it's the class code.
Oh, the code for the class?
Yeah.
Yeah, we'll do that too. So, all right, so this is us here? No, this is us here. 20-1. Okay, so we go to about. Okay, so make sure you're in the Google Classroom because that way anything I put on there, I can put up some hints and tricks and whatever. And then I'm gonna put this on YouTube, and I'll put the link on this as well. I know the beginning is kind of like, oh, he's not really saying anything. No, I'm not. So let's keep it moving. All right, that's the code. Make sure you have that so that you're in, and then we can kind of go from there. So now, if you go to Mathtopia, the link to Mathtopia is here. Okay, and then here's the book. Okay, go to chapter 3. Everything that we're talking about factoring is already in there. So just go back, try a couple questions. It's right there, the electronic copies for you. Try a couple questions just so that you feel a little bit more comfortable with the material. Okay. We also said that even if it looks complex, in this section, it's going to be in the pattern, right? So it's going to be in the pattern of ax squared plus b at x plus c, okay? If b at x is missing, investigate. It might be a difference of squares. We'll know it's a difference of squares if this number and this number are perfect squares and there's a subtraction symbol in between, okay? So just learn to recognize that pattern because you're just going to save yourself a lot of time. I can solve it via decomposition. I can, okay? But you're just writing extra lines that you don't have to write if you can see that pattern earlier, okay? So now let's take a look at number 6. Okay, so what are the factors of each expression? So now we can take this idea and we can apply it to these, okay? Because if I let these quantities just equal one variable, I'll recognize the pattern. So I can let 5b minus 3 equal x, okay? So let it equal x, then I can rewrite this as 4x squared plus 10x minus 6. Right? Now that I've done that, there's a couple of approaches I can take. I can factor out a 2 and then solve it that way. Or I can multiply 4 times negative 6. I know that that becomes negative 24. So two things that multiply to become negative 24 yet add up to become positive 10. What are they? 12 and 2, right? So now we can say, oh, all right, it's 12 and 2. right? I might put the 12 next to the 6 because I kind of see that early that there's factors there that they have in common. Is it really going to change anything? 90% of the time, no, right? But it's always convenient. So I go plus. Do I go plus or minus here? Plus or minus here?
Minus.
Minus. Okay? So minus 2x plus 12x minus 6. Now we're going to do factoring by decomposition, so we're just going to make our two little groups, right? In our two little groups, I can factor out. On this side, I can factor out a 6, so I'm going to do that. Times 2x minus 1, right? On this side, I'm going to factor out a 2x. And that leaves me with a 2x minus 1 as well. Now, I write down the thing that's the same only once. And then I write down what's left only once.
What if they're not the same?
They have to be the same. If they're not the same, you made a mistake. You factored out the wrong thing. And like I said, 90% of the time, it's not going to matter where you put these numbers. But try to just see earlier easy factors question.
Why do you only write them? Because you're factoring them both out.
So this is why. Because first I looked at it as two smaller groups. Now I'm looking at it as one large group. Right? So that's why I'm writing it down only once. Because I'm saying, oh, between these two groups, they have a common factor. Right? The common factor is 2x minus 1. And then that's what's left over in that. Okay? So we've like gone meta. We said, oh, we let this be x, and now we're kind of letting this be one quantity as well. Okay? Layers upon layers upon layers. Anyways. Now, our next part is to put this back in. So now we'll change x to 5b minus 3. So then we're going to have 2 times 5b minus 3 minus 1. Okay, that's on one side. So we make sure that that stays in its bracket. And then over here, we're also going to have 2 times 5b minus 3, but this time plus 6, because that's what it's like on the other side. Now when I multiply in, let's just go upstairs here. Okay. Now when I multiply in, I'm going to have 10b minus 6 minus 1. Okay, so 10b minus 6 minus 1, well, that's 10b minus 7. Okay. Over here, I'm going to have 10b minus 6 plus 6. Oh, well, sorry, 10b minus 6.
3.
2.
6. You're right.
Yeah,
Never mind.
right? It's all good. It's all good. 2 is a distributive property. So minus 6 plus 6, so that makes it 0. So all I have on the other side is 10b. Okay? And that's it. That's the factor of it. Yes?
How'd you do like B though? Because the things in the brackets aren't the same, like so you can't just be like let X equal whatever.
I was going to say, let me take a picture of this, but I'm taking a picture of it. I'm taking millions of pictures per second. Anyways, that's silly. So now, but I can take a picture of it actually by pressing camera.
Like I get that.
Anyways, while the video's going on. So now, let's do the next one, okay? Let's erase all this. Okay? If you don't have it, you can go back and watch the video. It'll be great. There'll be jokes to be had. It'll be good times.
Is it
Right.
going to be on Google Classroom?
It'll be on Google Classroom all over the internets. Okay? So now, sometimes my sister will, she'll send me a message on Facebook, and I'm like, dude, like, just text me. We don't need the whole of the internet to know our conversation, right? But anyways, some people like that, so that's a thing. So now, this part here. We'll take this quantity, and they're not the same. Are they the same? No, they're not the same. So one has to equal one variable, and the other one has to equal another variable. Okay? I can pick any two variables, so I'm just going to say that this one is going to be, I don't know, y, and this one's going to be z. Okay? I'm going to let x squared plus 1 equal y, and I'm going to let 2x equal z. So when I rewrite it, I'm going to have 16 y squared minus 4 z squared. Okay? So now it's easier to look at, right? And we can say, oh, wait, that one's a perfect square, that one's a perfect square, b at x is missing, and there's a negative in between. Okay? So now I can rewrite this as a difference of squares. 4 times 4 is 16. 2 times 2 is 4. So I can say, all right, so well, here's 4y minus 2z. Let's put this through it. Little script z. That's not script z. This is script z, but really it looks like a donkey tail, so we don't need that right now. So now, and then we can say 4y plus 2z. Okay? And then we just step back in again. Once we sub back in, we're going to have 4 times x squared plus 1 minus 2 times 2x, super bracket, other super bracket, and then we'll say 4, I'm going to try to write a little bit smaller, times x squared plus 1, okay, plus 2 times 2x, right? Then we use our distributive property and multiply in. So we'll get, I'm going to move it over, I'm going to shift it over a little bit. So then we're going to get 4x squared plus 4 minus 4x. Okay, we'll clean that up in a second. And over here we're going to get 4x squared plus 4 plus 4x. Okay. Then, it's always best when we write our polynomials to write them in descending order. It's a nice thing. Okay? Okay. Now, can we factor out a 4?
Yeah.
Okay, we can factor out a 4. Even if we do factor out a 4, let's just do our little logic test here. 4 times 4 is 16. Two things that multiply to become 16, but add up to become negative 4. Do we have that? Can we consider that? Can we think of anything there? Okay, I can't really think of anything right now. Not off the top of my head. Okay. I'm thinking that this is probably where this question ends. Okay? So we can just leave that. I mean, we might be able to factor out a 4, but I don't think that's going to change anything. Because then we have two things that multiply to become 1, if I factor out the 4. Okay? Two things that multiply to become 1, but add up to become 1. Right? And then here we have two things that multiply to become 1, but then add up to become negative 1. We can leave it there for now. Okay? You might want to put it in vertex form and then solve there is a number, but we don't have to do that right now. Yes?
So are there brackets like around the entire final equation? Because in the back of the book, it says that the answer would be 16, and then in brackets, x squared minus x plus 1 bracket, and then that again in a separate set of brackets.
Minus x plus 1.
Like, why wouldn't you have it separately? Like, are those...
Why would we have it separately?
You know, like, why wouldn't you have 16 in front of one set of brackets and then 16 in front of the other set of brackets?
Why 16? Wouldn't it be 4?
Wouldn't it be 4?
It says
It says
16.
All right, well, let's look at that closer. Okay? We've done everything we need to do in this, right? This is 4. This is 4. Okay? So, and then we have our separate parts. The book might actually take an approach where we're saying, all right, there's a further simplification we can do here, all right? But our mechanics are pretty sound here. Can anyone identify any errors that I might have made? So, once we get to this part here, we're going to have to decide if there's a way to further simplify this quantity that we're looking at. Okay?
Just factor over 4, and that'll be your final answer.
Okay, so there was a 16 in front, right? Okay, why do you think there's a 16 in front? If I factor out a 4 out of here, let's do that. We factor out a 4 out of here, then there's going to be a little 4 here, right?
Yeah.
And then there's going to be a little 4 here,
Yeah.
right? 4 times 4 is, right? Because I'm multiplying everything times each other. Right. So I can take a 16 and that's going to be over here. Does that make sense to you? All right, let me show you. Okay?
Oh my goodness.
So let's factor out that 4. We'll factor out that 4. Okay? And then it's times this quantity on the inside. I see what they did now. Okay? So x squared minus x, okay, plus 1. Okay? And then we factor out another 4. Let's make space for that guy. Hey, other number 4, welcome to the party. You got lovely hair. Oh my goodness. Who's your hair designer? You're such a lovely 4. Okay? And then x squared plus x plus 1. Okay? Oh, there's a 1. I need a 1 there. Well, these are being multiplied by each other, right? Right? So 4 times 4 is 16. So I can just write that 16 one time, and that'll be on the outside. Does that make sense now?
Why do you multiply the 4 and the 4?
The two brackets aren't the same though, because it's a negative x and a positive x.
The two brackets, these are my two brackets, right? This is the quantity from this bracket. This is the quantity from this bracket. Okay? And I've discovered that I can take a 4 out of that. They're all being multiplied by each other. This is 4 times this. This is 4 times that. This is times this as well. Right? So if we just do it in steps, we can say, oh, 4 times 4, I can multiply these two together first. And I can say 4 times 4 is 16. And then it'll be 16 times this quantity times this quantity.
So you wouldn't have a 16 in front of both brackets?
No.
Okay.
We'd be doubling everything, right? So, again, is that germane to our understanding of this section? No, it's not. That's just like fancy math stuff we're doing here at the end. Yes?
So if there's ever a case where there's the same number in front of both the brackets, would you just multiply them together then and put it? Would you always do that?
So if there's ever a case where it looks like this, should we do the thing? That's what you're saying,
Yeah,
right?
do we always multiply them?
But I want you to consider that sort of brute force approach doesn't really lend to the elegance of what they did, right? It's just saying, like, we can't categorize every single type of problem we might see and then say, do this when that happens, or then do this when that happens, and then when it kind of looks like this, do that. It would be better to say, well, I know that these things are being multiplied together. X times, I'm putting just variables here, right? X times Y times Y, right? So I could have it like that. Or I can say it's x squared times y squared, right? That's what we did here. Got x times y times z, because these aren't the same. And then I just said, oh, well, let's just make this x squared. That's all. Hey, I like that. Oh, good. We did a thing. That was nice.